Hello, and welcome to the continuing series we call Lab Zero. If you've seen any of our other previous videos, then you'll probably know that we call it Lab Zero because it helps guide students with the prerequisites needed before tackling your very first hands-on lab in INE's Cybersecurity Virtual Lab environment. This short video introduces virtualization, an integral component of modern IT, and how virtual machines are used extensively by cybersecurity professionals. Let's review what you'll need to properly participate in the entire Lab Zero series, and then what you'll learn in this video. Since we're covering just the basics of virtual machines, there won't be any live demos. However, to complete the rest of the Lab Zero series and successfully connect to the INE Virtual Labs, you will need a few things. Now, we've covered this list in other Lab Zero videos, so I'll go over it a little quicker this time. First and foremost, you'll need an INE account. Most of you have this already, but since this video is also on our YouTube channel, some may not. Honestly, any account will do, because even our free starter pass comes with the entire Penetration Testing Student Learning Path, or PTS for short. PTS is the course we recommend to all as their first venture into our cybersecurity content, and Lab Zero will help you get the most out of your experience. Because most security tools are made for Linux, and many tools are only available on Linux, it is an absolute requirement for any security job for you to be familiar with Linux. Now, we prefer Kali and Parrot for beginners because they are purpose-built Linux distributions with most cybersecurity tools pre-installed and ready to go. We also recommend using a virtual machine and, more specifically, a virtual appliance version of Parrot or Kali on your Windows or Mac devices. If you're not familiar with these terms, don't worry. I kind of assume that that's why you're here, and we'll get to that in just a minute. Now, before attempting to connect to your very first cybersecurity lab within the INE platform, well, being familiar with virtual machines, Linux, and virtual private networks is extremely helpful. If you're not, again, don't worry. That's exactly why we created Lab Zero. And be sure to look out for other videos in this series for a gentle introduction to each of those topics. We also produced the INE Cybersecurity User Guide as a step-by-step reference. Links to it can be found throughout our cybersecurity courses, so keep an eye out for that. So first, what are we going to do today? Well, we're going to attempt to define what virtual machines are by looking back at history and how we got to today with pictures. Then, there's this word that you may have heard, Hypervisor. Well, what is it and why does it matter? Now, after getting a general understanding of how virtual machines work, then we'll explore what types of VMs are available and the difference between a virtual machine and a virtual appliance. We'll cover the many different virtualization products out there and what our recommendation is. We'll close out by repeating that mantra that if you really want to succeed in becoming a successful security professional, then you must learn Linux. We're going to say it numerous times throughout this entire Lab Zero series. And, of course, in this particular video, how utilizing virtual machines can make this much easier for you. All right, so what is a virtual machine and why do we need them? Well, if a picture's worth 1,000 words, then, well, why not share 5? Now, trust me, I'm not going to wax on for 5,000 words, but let's cover a little history of computing and how we got to the idea of virtual machines. Well, first on your screen, we have the ENIAC machine, the first programmable electronic general-purpose digital computer. When first put to use in 1945, it had no internal storage, only punch cards. Now, quoting Wikipedia, by the end of its operation in 1956, 11 years later, ENIAC contained 18,000 vacuum tubes, 70,000 resistors, approximately 5 million hand-soldered joints, and it weighed more than 30 short tons, occupied 1,800 square feet, and consumed 150 kilowatts of electricity. Well, I guess you have to start somewhere. Now let's move on to our next picture, where we see a graph of the famous Moore's Law, named after Gordon Moore, the co-founder of Fairchild Semiconductor and Intel. Also, according to Wikipedia, Moore's Law is the observation that the number of transistors in a dense integrated circuit doubles about every 2 years. Now, there's other laws dealing with the size of semiconductors and other components, but I think you get the idea. Which brings us to the Osborne 1 from 1981. Although it is known as the first commercially successful portable computer, well, it had no battery and can only be powered by being plugged into a wall. It was the size and weight of a fully packed suitcase, but it had a handle, so I guess it's portable, right? It also, just like the ENIAC, did not have any internal storage. Instead, it came with two 5 1/4 floppy drives, along with a Z80 processor running at 4 MHz with a whopping 64K of RAM. Okay, so not blazing, hardly portable, and pretty laughable by today's standards, but look at the massive leap in technology from the ENIAC. And then compare it to today's top processors like AMD's third iteration of the EPYC with 64 cores, 128 threads, and a boost clock of up to 3.675 gigahertz. Now, even a single core of one of EPYC's processing power is actually more than it took to get to the moon, and it has 64 of those cores. Now, add that to the size of internal storage these days, such as Seagate eventually aiming to have 100 terabyte hard drives by 2030. And this is obviously more than most can utilize for only one system. Well, wink, wink, nod, nod. I think you kind of see where I'm going with this. So these days, if we have so much processing power in our machines that we're not using all of it, well, what could we possibly do with all that excess? Well, just imagine a computer that had all that power. And it's not just the CPU and the internal drive. It's every component that has utilization to spare. What if we could use the excess to make multiple machines in a single piece of hardware? All right, so let's take a break for a second. I want to do a little thought detour for just a moment. When you set up a computer, it has to have an operating system. We're usually familiar with Windows, OS X, Linux, but there are others. Well, that's just software that gives us humans an environment in which to interact with the hardware inside the machine. Well, if it's just software, then it's easy to make copies of that software or move it wherever you want. It's kind of like a backup. Imagine if we sectioned off parts of the hardware that we aren't using and dedicated to copies of operating systems, and not just those backup copies, but copies of the operating systems that we could actually interact with as though they were completely separate machines that just so happen to live in the same housing. Well, in a nutshell, that's virtual machines. So, looking at your screen, we have a computer case on the left with the screen and keyboard on the right. Well, we can create numerous computers within a computer virtually. Then all we have to do is take the internal hardware components, your drive, CPU, RAM, and a network card, and then portion it out for each virtual machine. So, I can dedicate a little storage to the first one. How about grabbing a CPU core or two from the 64 in the EPYC processor? Well, we can take some of our underutilized RAM and then also maybe add some network resources. Well, I can also do it again for yet another virtual machine. And I can keep doing it until I run out of spare resources. Now, please remember this. This is utilizing spare resources. We still have to keep enough for our main machine, also known as the host, to be able to continue running without issue. Now, the software that allows the management of your host's hardware resources and the virtual machine themselves is called a hypervisor. You might say a hyper what? A hypervisor. Now, the easiest way to think of a hypervisor is by another name that it is known, and that is a virtual machine manager, or VMM. It not only manages the hardware resources, but also creates and maintains the bubble in which each virtual machine lives. Now, it also makes sure that each VM is isolated for security purposes. There are two types of hypervisors. What we see on the screen is Type 2. A Type 2 hypervisor requires not only the underlying hardware you see at the bottom layer, but also the operating system in order to run on that you see in the second layer from the bottom. Now, there are Type 2 hypervisors for Linux, but in our case, let's just focus on running our Type 2 hypervisor on either Windows or OS X. Now, as you could guess, because there's a Type 2 hypervisor, there also is a Type 1 hypervisor. A Type 1 hypervisor eliminates the need for a host OS, so we can get rid of that second layer from the bottom, because a Type 1 hypervisor acts as a very limited operating system on its own to handle just enough to get the hardware running, and then it continues its work as a virtual machine manager. Now, most people, especially in security, get into running virtual machines to test other operating systems and how they'll react to your hacking techniques. And of course, those operating systems they want to use are Linux, and they want to do this all without the need for extra hardware, as we explained earlier. And as you can see from the top layer on the screen, if we have enough resources, we can run more than one machine of the same or even a different operating system all at the same time. But that's not all. We can run other types of virtual machines like switches and firewalls. Well, that begs the question, well, what other types of VMs can we run? Well, we all know about operating systems like Windows, OS, and of course Linux, because we keep going on and on about that, but that's just on the client side. We can also run server operating systems as well. Not only that, but we can dedicate those servers to running specific tasks, like a web server, a file server, a domain controller handling Active Directory, DNS, and even a mail server. But it doesn't end there. As long as we can break it all down into just being software, well, we can even run virtual switches, routers, firewalls, intrusion detection and prevention systems. In the end, if it can be installed on a blank partition of a drive, whether that's real or virtual, well, it could be virtualized. Well, that kind of brings me to another point, though. I use the word partition. Some of you may not even know what a partition of a drive is. Or, if you do, maybe you've never installed Linux on either an empty physical machine or an empty virtual machine before, and it makes you kind of nervous. Or, if you can install operating systems on your own with no problem, well, what does each machine require for what you may want to try and do because you haven't learned that yet? How much RAM, how much hard drive space, and so on. Well, what about also if you've never run a web server before? Well, what additional software do I need to install in order to turn my server into a web server? Do you know how to do that? Well, believe it or not, there's actually a solution that makes this even easier for you to get going with very little knowledge. And that's called a virtual appliance. A virtual appliance is a pre-packaged virtual machine that has everything already set up for you in advance. All you have to do is download a single OVA file and import that file into your favorite virtual machine manager software, and it takes care of the rest for you. Now, these gifts from the tech gods come in many different flavors, from common OSs that come pre-configured with built-in tools or functionality like Parrot or Kali, as we've often mentioned. But you can also get appliances that are purposely vulnerable machines or web apps so you can practice your newfound hacking skills without hurting anyone's production systems. Well, there's also networking devices from specific vendors to, maybe practice for your certification exams. You can also have a server with a database all ready to go for you. How about a full Linux install with Apache, MySQL, and PHP for an easy web server? Well, if you're playing with web servers, well, some of those virtual appliances even come with WordPress or other content management systems already set up inside. And of course, there's the latest tech to play with for machine learning and big data analytics. And the list can go on and on. But that, of course, leads us directly into our next question. Well, what exactly are my options when it comes to virtualization software? Well, keep in mind that there's enterprise class virtualization software, but that's meant for these massive data centers where the servers are meant to be live 24/7, 365, or at least 5 nines for those who are not familiar with that term. That would be 99.999% uptime. Well, that's not what we're trying to focus on today. So all of that stuff for the enterprise, well, that's not for us. What we want to focus on, and you're seeing on the screen now, is software that's meant for the end user's laptop or desktop. Now, the big player on the scene is VMware. VMware Workstation comes in a paid pro version, and there's a more limited free version, and that's called VMware Player, and it's also available for Windows and Linux. There's also VMware Fusion, and that's their Mac version. There's also a ton of other products like Hyper-V by Microsoft, and that comes for both Windows and Linux. You have Genome Boxes for Linux, QEMU for Linux, Citrix Virtual Desktops, which was formerly known as Zen Desktop, and that's for Windows. You also have Parallels, which can be used for both Mac and Windows. You also have Red Hat, which again can be used for Linux and Windows. And of course, you have Boot Camp made by Apple specifically for Macs. Whew, that's a lot. But believe it or not, that's not even all of them. But I'm sure, as you can see, the screen was already getting a little crowded. Well, good thing that we actually did all of the evaluating for you. So with that, based on it being free, the numerous platforms for which it's available, its feature set, and the usage in the security community, well, we chose Oracle's VirtualBox. All right, now that we know what software to use, we can get to our mantra for most of this Lab Zero series, and that is you must learn Linux. And as we've also reminded all of you incessantly, and again, you're going to keep hearing it, but please use Parrot or Kali, especially if you are new and trying to tackle those PTS labs. Now, this is really important to use these distributions because not only is OpenVPN included in both of these hacking-focused Linux distros, and that's the software you're going to use to connect to the labs. If you're not familiar with that, go check out our VPN video in the Lab Zero series. But also included in these hacking-focused Linux distros are most of the tools that you'll need to complete the INE courseware. So, from here on out, whenever you think of tackling any of the INE CyberSec labs, please use Parrot or Kali. If you try to run anything else, okay, that's fine, that's up to you. But if you end up having an issue in the lab and you contact support at INE.com, well, we're going to start by asking, hey, are you using a virtual appliance? And if so, are you using Kali or Parrot in a virtual appliance version of that virtual machine? All right, so now you know what software to use and you know what operating systems to go get. Well, now that should be pretty easy for you to set up your very own lab environment in order to tackle the INE cybersecurity labs. Well, if you think you can handle installing a few items and accepting the default values along the way, well, then it's time for you to do just that. So let's get ready for PTS Student Learning Path by setting up your virtual learning platform. And all you have to do is follow these steps. So go to the downloads page of virtualbox.org. Now you need to get both the platform package of your choice, usually in this case it's going to be Windows or OS X, as well as the VirtualBox Extension Pack. Now it's very important to remember to verify that both are of the same version. Now, this is more important if you're upgrading later, but it's always good to mention it now. So install the platform package first, then install the extension pack second, specifically in that order. Next is to grab the OVA file of your choice of either Parrot or Kali, and the links are provided. Then the next thing to do is to open VirtualBox and import the OVA file that you just downloaded. Now, after importing and accepting the default options during that importing process, well, you're ready to go. All you have to do is, within VirtualBox, you'll see it listed on the left-hand side, you highlight it on the left-hand side, and you click, there's a big start button. And that's all there is to it. Go for it. You're ready. We're done. Well, of course I made that sound pretty easy, right? Well, for some it is. And if it is, you know what? Go for it. Knock yourself out. But for those who are new to all of this, we understand that it might not be. And again, this is Lab 0. So for a more detailed walkthrough of these next steps, tune into other videos in this series. We'll have one with a live demo for setting up Parrot in VirtualBox, and then we'll have another separate video with a live recording for doing the same thing but with Kali. All right, before I let you loose on the virtual world, let me first say that we hope you enjoyed this lesson on what's a virtual machine. And one more time, since this is also available on INE's YouTube channel, you may not have an INE account in order to play along. So if you'd like to get your hacking career kickstarted, go get the free INE Starter Pass, and that gives you access to numerous course snippets as well as a full learning path in each of our training categories of cybersecurity, networking, cloud, data science, and even more. The free learning path that comes with our cybersecurity content is PTS, and that comes with all the slides, videos, and unlimited time in the PTS virtual lab environment. But it also comes with 3 complete black box scenarios which mimic real-world pen testing jobs to prepare you not only for the job, but the eLearn Security EJPT certification exam. Now keep in mind that that exam voucher is not included with the Starter Pass, but the Starter Pass is free for everyone. So head on over to INE.com and give it a try. You've got nothing to lose and a life-changing career move to gain. Thank you for joining us, and happy hacking!